Welcome. This is Lesson 7 in Unit 5. This is Mr. Jordan and
Mr. Turris.
And we're going to go through how to solve systems of inequalities. One of the more important things you need to recognize is when we graph inequalities, when they are in the form y equals, let's say, 2x plus 5 is an equation, we know how to graph that. But what if I just substitute an equal sign with a greater than symbol? The only thing that changes, guys, is that our line will be dashed. And I'm going to ask you to make a note every time we see an inequality, whether it be a dashed line or a solid line. And when it's greater than or less than, it's dashed. And it's solid when it's greater than or equal to or less than or equal to. The other thing is that we're going to make a note as whether it's above or below the inequality. So very simply, it means when you have a greater than or equal to symbol, you're going to always shade above. One reason you can think of it is that the word greater than sort of implies that it's above it. If you have less than or less than to equal symbol, you're going to shade below the line. So for example, in the line example I gave you above, that's pretty easy. The line y equals 2xb would look like this, but the inequality y greater than 2x plus b would be a dash. And let's take a look at some more difficult ones in our notes. We have what we call a system of inequalities. We have two equations, a yellow equation and a blue equation. And because there's an inequality, we call them inequalities. And because there's two of them, we call it a system of inequalities. We're going to test to see if the point 38 first is part of that. So the first thing I want you to do is write down the inequality you're going to test first, which is the blue one. Go ahead and write it down for me. And so one good idea to do this before we start is to write down what x and y is explicitly. X equals 3 and y equals 8. I got it. All right, so now we're just done. We know our x and our y's. We're going to plug them in. So wherever I see an x, I plug in a 3. Wherever I see a y, I plug in an 8. We add them up to see if they truly are greater than... Oh, I made a mistake. That's okay. It's going to be 11 is greater than 10, and that is true. And so this point satisfies the top inequality, but does the point satisfy the second inequality as well? We write the equation y is greater than or equal to 3x minus 5. So I'm testing the second equation, and I'm going to solve for it by substituting the same x and y into it to see if it's valid. I'm going to use parentheses because the numbers bump up against each other, and then I solve for it, and I get 9 minus 5, and 8 is indeed greater than or equal to 4. Yes. So algebraically, we just proved that this point is a solution to both the entire system because we checked the first and second inequality.
Hi everyone, this is Mr. Turris. So I'm going to be moving on to part B of this question. So if you have not written down the part A work, I suggest that you pause, copy down this work, and before I erase it. So now I'm going to start the new one. Okay, so we're going to be doing the same steps as we did for part A. We see that the point we're trying to substitute into our system of inequality is 5, 9, showing that our x value is 5 and our y value is 9. If I write out my two inequalities, I'm going to check if it holds each inequality true. So my first inequality was x plus 9 is greater than 10. If I substitute in my x and y, I'm going to do this. Get 10, and then when I solve it, I will be getting 14 is greater than 10. And since 14 is greater than 10, we know that if I were to plug in this coordinate into that inequality, it would hold true. Then I'm going to use the next inequality, which we know is y is less than or equal, greater than or equal to 3x minus 5. So again, we're going to substitute in 5 and 9 to each variable. I'm going to pause this and see if you can do this on your own, and then I will come back with the solution after. Okay, so I substituted in my two variables and I got that 9 was greater than or equal to 10, but we know that is not true. So if I were to plug in the coordinate 5, 9 to my second inequality, I knew that would hold false. So it's not true or false. So now Mr. Jordan is going to show you how to graph the solution set, which would bring us back to the information he was telling us earlier about shading. So that is an important part of this lesson.
All right, to graph each equation, we're going to write them down and then analyze them. So go ahead and write down each yellow and blue equation once more. So we have x plus y is greater than 10. We also have the equation y is greater than or equal to the equation 3x minus 5. Next I'm going to figure out the slope, intercept, dash, dot, or shading for each equation. For the blue equation, I need to modify it a bit by solving for y, so it's y equals. And to do that, I'm going to minus x from both sides. I get y is greater than negative x because I minus x from both sides, plus 10. I wrote it there because now I can identify the slope, the y-intercept very easily. The slope is going to be negative 1. It's going to be the number that's in front of the x. Then I'm going to find the y-intercept, which is going to be 10. Then I have to identify this as dashed or solid, and because the symbol is greater than but not equal to, I'm going to indicate that it's going to be a dashed line, or dotted, by the way. You can use dots too. It's going to be a dashed line, and it's going to be above, so it's going to be shade above. These are the four things that we're going to need for each inequality when we graph them. You'll need to know the slope, the y-intercept, whether it's dashed or above. Try the same for this next yellow equation. I'll pause it now, pause your video if you'd like, and go ahead and solve for the four ideas there. So we have the slope equal 3, the y-intercept equals negative 5. Because it's greater than or equal to, it's going to be a solid line, and it's going to be greater than. All right, greater than. So at this point, we're going to start graphing the yellow line, or the blue line, and we'll start finding the intercept. We know it's going to be at positive 10, so we go up to positive 10. I'm counting by 2's. So we know the intercept is 10, but we know the slope is going to be down 1 over 1. So I'm going to connect dots until I see a pattern, and it might save some time by going down 2 over 2. And then after recall, is this going to be dashed? And is it going to be shaded above or below, or is it a solid line? Because it's going to be dashed, it's dashed because it's greater than, but not greater than or equal to. And so we're going to shade it in above that line after we label the equation. So we label our equation from its original form. Next, I want you to pause the video and try the yellow function. Next, so go ahead and make this a solid or dashed line based on an idea of greater than or equal to. It's a solid line because it's, again, equal to that value. And then we write our equation next to it. And that's the equation in original form, which matches this form. Next, let's think about how we shade these regions in. If you're using a pencil, just use lines. I'm going to use a highlighter sometimes, or a pen. And the blue one is above, so I just make little lines above it. And don't darken it too dark, because you're going to see why later. The yellow one is greater than as well, so if it was a roof, it would be greater than the roof, which would be on top of the roof. You'll see a double hash region where that's our actual solution. So put a big S in the double shaded region right there. That's our solution, and any points that are in that solution area or region is our actual solution. So I'm not going to put them exactly, but if we looked at the first points, like 3, 8, and 5, 9, 3, 8 would be in that solution, like right around there, and 5, 9, though, would be outside of that yellow-blue region, it would just be in the blue region, which is not a solution to the systems. That's not exactly right, but that's about close enough. And it proves that we have it. So let's move down to the next one. We have these two equations, and we're going to have a red equation and a blue equation. We're going to identify the four important numbers to graph inequalities, which is identify their slope. So the slope of the red equation is -3/2, and the y-intercept, which is going to be +2. The blue equation, though, is a little tricky. The blue equation is a line that says x is greater than or equal to -2. So it's going to be all values of x that are greater than or equal to -2. It's going to be a vertical line. So its slope is actually undefined. It's just, we're going to describe it as a vertical line. All right, and it has no y-intercept. It never actually hits the y-axis because it just goes up and down. One point that's in the solution, well, we're going to need to graph it. So let's go ahead and graph each of these lines. We learned how to graph the red one before. We didn't take the y-intercept of +2 and the slope of down 3/2 and make a line that would be dashed or solid, shaded above or below. Let's take a look at that. It should be a dashed line because it's not equal to, and it should be below the line, or in this case the dashed line. The next one, we're going to look for values that are greater than -2, and so it's sort of, we think of it as above. So we start with our point, y-intercept of 2. We're going to go down 3 and then over 2 for our next point. And then another point is down 3 from there, -2. The nice thing is we can go the opposite direction, which means we go over 2 and up 3. And we connect them with a dashed line. That's the most important part. It's the most missed part of graphing inequality. So please be careful there. Label it too. That's a common. That's not as important, but it's important. So make sure we label it as he originally wrote, which is pretty simple. It's the same as what we had. And then the next one is hard for new students. What do we have when x equals -2? Well, please put a dot at x equals -2. Oh, yeah, we should shade it, and we'll shade it below. Now let's move on to the blue one. The blue one is literally x equals -2. So please put a dot at x equals -2. And then literally it's going to be all values where x equals -2. And if you made dots going up and down where all values of x equals -2, you'd create a vertical line. And that vertical line would be solid because it says greater than or equal to. And if it was greater than -2, it would move to the left or to the right. Well, we know from number line graphing that it would move to the right because it's greater than, it's pointing in that direction. So we shade in the solutions, everything to the right. The next part is the solution, which is the double shaded region. So mark that, and then find a point that's in the solution set. Find a very easy one that's easy to graph and easy to see. For me, the origin is always a really easy. Is the origin in the solution set or not in the solution set? That little point right there is in the double shaded region, so that's a point in the solution set. And then a point not in the solution set, just something that's extremely out of it. Don't go next to the borders. Try to find a point outside of it. So I'm going to go all the way to -5 to the left, and that gets me safely out of the region. And that is definitely not in the solution set. It's a solution to the red inequality, but not to the blue one. The next equation, go ahead and I'll pause the video. There's an inequality there. Try to find out which of these points is a solution to both inequalities. All right, try that now for me, please, and then unpause the video for the solution. All right, so the solution is option 3, -2. If you plug in -2 for x for both of them, and y for 10, you'll get that both inequalities are valid. That concludes this part. There'll be another video for exercise 4.